Today, we're diving straight into the mind-bending engineering and sheer scale behind some of the world's most powerful military machines. We're going to look objectively at the raw data, the unbelievable speeds, and the mechanical power defining modern warfare. From machines holding the ground right in front of us to weapons that can literally span the globe in minutes, the technology we're unpacking today is absolutely fascinating and, honestly, pretty terrifying. Here is our roadmap for today. We'll be hitting 4 key areas: robotic tanks on the field, automated defense and area denial, mobile artillery and interception, and finally, the global nuclear threat. Let's get right into it. Section 1. Robotic tanks on the field, or as I like to call it, the new ground game. So if we really want to understand how robotic tanks dominate fields, we have to look at how they completely remove human frailty from the equation. When you think of a traditional battlefield, you usually picture human infantry, right? Well, modern engineering is literally designing flesh out of the environment. Take the Russian Ra-9, for example. It is a remote-controlled behemoth. We're talking 10 tons of armor packed with 4 anti-tank missiles, a 30mm gun, flamethrowers, and a machine gun. It's built purely for raw, frontline aggression. On the flip side, you have the German Rheinmetall Mission Master. This one acts as a highly versatile tactical carrier, navigating hard-to-reach places, hauling up to 600 kilograms of weapons and gear for soldiers, all while packing its own 140mm rockets. Both perfectly illustrate how robotics are totally taking over heavy combat. Think about this. Just a dozen of these machines can completely lock down and patrol an area spanning several kilometers, because standard human small-caliber weapons literally just bounce right off this impervious armor, and absolute tactical asymmetry is created. Manpower suddenly becomes a liability rather than an asset, fundamentally changing how ground territory is secured and why robotic tanks dominate fields today. Moving right along to Section 2, automated defense and area denial. The speed of Skynet. 6,000. That is the staggering rounds per minute of the American Profunds M134 minigun, the only machine gun in the world capable of fully remote operation. To put that into perspective, that's 100 rounds every single second. When human reflexes simply aren't fast enough, automation takes over. At that speed, human intervention is actually a bottleneck. When paired with advanced targeting, a totally automated platform unleashes this rate of fire faster and more accurately than any person ever could. We see the same kind of automated volume with the Russian AK-630 M2 Duet, too. It's an automatic rotary cannon firing 1,000 rounds per minute to destroy targets up to 5 kilometers away. Shooting so incredibly fast, it visually just resembles a continuous flamethrower. To really wrap your head around automated speed, consider the Russian S-400 anti-aircraft system. It neutralizes targets moving faster than the fastest rockets on Earth in mere seconds. The Zircon missile, the fastest rocket in the world, travels at 3 kilometers per second. That is fast enough to orbit the entire Earth in just 4 hours. But the S-400 Triumph system, it can destroy aerial targets moving up to 5 kilometers per second. It takes the system a mere 2 to 3 seconds to lock onto all targets within a 600-kilometer radius and up to 100 kilometers high. The sheer computing power required to calculate and intercept a target moving at those velocities is just mind-boggling. Now, looking objectively at area denial, let's talk about munitions that are banned in 108 countries. They secure vast territories almost instantly, but leave a lingering, completely indiscriminate threat. Historically, to deny an area to an enemy, you had to send engineers out to painstakingly lay minefields by hand. Well, the CBU-89 changes that in a flash. A single 450-kilogram drop opens in midair, scattering 432 anti-tank and 132 anti-personnel mines across the terrain. And they remain active for over a month. Another variant, the CBU-58, historically packed 650 baseball-sized explosives into just one drop. This right here is exactly why they are considered one of the most inhumane weapons globally. Their automated efficiency comes at the heavy cost of total unpredictability. All right, Section 3, mobile artillery and interception, basically shoot and scoot. The Swedish-designed Archer artillery system has mastered this wild 1 minute and 14-second loop, making it virtually impossible to track. It takes just 23 seconds for it to stop, turn around, and fire its first 155mm shot. Within 74 seconds total, it's alerted, fires 3 rounds, and is already driving away to a new location while its own projectiles are still flying through the air. By the time an enemy calculates where the shots came from to return fire, the Archer is simply gone,
getting ready to unleash another 8 rounds a minute from somewhere else entirely.
To put this abstract data into perspective, imagine an area the size of 67 baseball fields burning in just over half a minute. That is the terrifying scale of modern MLRS arrays. Take the TOS-1A. It's a tank base loaded with 24 thermobaric rockets. Thermobaric weapons actually spray a fuel cloud and ignite it, forcing the fuel inside enemy equipment to combust. It can blanket 4 baseball fields of land in just 6 seconds, though its range is limited to 6 kilometers. But if you need to reach out further, the 9A52-2 Smirch steps in. It fires 12 massive 300mm rockets up to 120 kilometers away, unleashing its full payload in 38 seconds to cover those 67 baseball fields. Imagine a convoy of 6 of these firing at once. The scale of destruction is almost impossible to picture. Zooming out even further, coastal systems like the Bastion P can lock down entire coastlines at supersonic speeds of 3,200 kilometers an hour. While the TOS-1A dominates the immediate 6 kilometers, the Bastion P reaches an incredible 350 kilometers out into the ocean. It uses the P-800 Onyx anti-ship cruise missile, an 8-meter, 3-ton weapon with a 300-kilogram warhead. Because it approaches targets at supersonic speeds, it's exceptionally difficult to detect or intercept. What's crazy is the launch vehicle finds a target, fires, and redeploys all in under 5 minutes. The data actually shows that just 30 of these fast-moving vehicles could protect the entire United States coastline.
And that brings us to Section 4, the global nuclear threat. Hemispheric reach.
288. That is the number of nuclear warheads a single U.S. Ohio-class submarine can carry across its 24 Trident II D5 rockets. There are 14 of these submarines in the U.S. fleet alone. Think about the engineering scale here. Each of the 24 missiles on board is 13 meters long. One of these subs can approach a coastline completely undetected, sitting silently at a depth of 30 meters and unleash an imperceptible payload that absolutely no missile defense system on the planet could simultaneously handle. Modern ballistic missiles have evolved way past carrying just a single bomb. Once a missile reaches an altitude of 100 kilometers, it actually deploys multiple independent warheads that hit separate targets with extreme precision. The Trident II carries up to 12. The Russian R-30 Bulava, which is also fired from submarines, contains 10 warheads, with each one being 10 times more powerful than the bomb dropped on Hiroshima. The RS-24 Yars carries 4 warheads over 12,000 kilometers. But the true giant in this category sits at the absolute limit of intercontinental range. The Russian RS-28 Sarmat is a monster. It is the world's largest and longest-range intercontinental ballistic missile. It weighs 200 tons and stands 35 meters tall. That's as tall as a 10-story building and as wide as a Boeing 737. It can hit a target 18,000 kilometers away, easily enough to fly entirely across Eurasia. A single launch drops 10 nuclear warheads, each weighing 1 ton and boasting a yield of 750 kilotons. But here is the really fascinating part. Because all major global missile defense radars are traditionally oriented to the west and east, the Sarmat is strategically designed to launch over the South Pole, rendering it effectively invisible to standard defense networks.
So, as we wrap up this explainer, I really want you to consider how extreme scale and automation are completely redefining the future of global security. We've seen how robotic tanks dominate fields by making human infantry physically obsolete. We've seen artillery that shoots and scoots way faster than radar can track it, and automated systems doing the math for intercepts at 5 kilometers per second. Warfare is no longer limited by human endurance or reflex times. As these highly automated, devastatingly fast, and globally reaching systems continue to evolve, we are left with a pretty terrifying reality to ponder. In a world where global conflict can be decided by algorithms and supersonic math in mere fractions of a second, is there even time left for a human to be in the loop? Thank you so much for joining me for this explainer today. Keep questioning, keep learning, and I'll catch you in the next one.